Word break. Have you ever broken your word? I'm a man of my word. All right, word break. Given a non-empty string S and a dictionary verdict containing a list of non-empty words, determine if S can be segmented into a space-separated sequence or one or more dictionary words. You may assume the dictionary does not contain duplicate words. For example, given lead code, all right, so we have lead and code in the dictionary, and return true because lead code contains lead and code. Okay. So updating the word list substring, please update. All right, never mind, doesn't matter. Anyway, so now first, if we want to do this in the most primitive way, then we would just iterate. We're gonna start from the first character, okay, and we're gonna go through the list and see. Well, first of all, what I would do is that I would convert this list into a set. I'll convert this list of dictionary into a set of dictionaries so that when we try to look it up, it will have constant time. The lookup time is constant time. We don't have to go through the entire list every time we try to look up a word. Okay, so now first step is now the conversion of the list. So this step, I'll just do it directly here. So it's going to be string, and we're going to have a dict, and it's going to be new hash set, and it's going to be string, and it will put word dict into it. Alright, so that's about it. Now it's the trick. So we can start from the first character and see, okay, if that is contained dictionary. If it is, we're going to start from there, and for example, we're going to start with a second character, and we're going to do, so in this case, we're going to do a depth search for the strings. So we're going to check one character byte at a time. So we're going to check one character, and then if it doesn't, and another character after that, and the 3. So it's going to be n to the power of n time, and the time complexity is n to the power of n time, because we have to do n times n times n times n times n to check that many times to check if the word is contained in the dictionary. Is that n to the power of n? Yeah. So can we do better? Yeah, I think yeah. So can we boil it down? Can we cut it down to n exponential, where we just need to check one step at a time. All right, one step. We just need to check one character at a time, and for each character, for a remaining character, so we're going to check one character at a time, and so we're going to check one character at a time. Now we're going to move one character at a time, and when we move, as we move forward, we're going to check the first half of the string has any word that is contained that comes from the dictionary. So the time complexity of that, it's going to be n exponential, because for every for every character, so n, we have to do an iteration of that, if you know what I mean. So what I'm going to do here is, what I'm going to do for I is equal to 0 and I less than, so let's say as length, well, first of all, I'll get the length of the string, and then we'll have the length, and we'll have I plus plus, and then for every string we are going to, for every substring, we're going to have I is equal to 0, j less than I, and then j plus plus. So for this substring, we're going to check, no, sorry, not this one. For this one, we're going to check if it contains a word or not from dictionary. Okay, now I think we can start. So the time is going to be exponential, but we can start from there. And okay, so now we need. So what happens if we have a word that is contained? We have a word that comes from dictionary, so we need to mark that position. So in order to mark that position, we need to have a Boolean array to mark if the current position has a word from the dictionary or not. Okay, so now we need a Boolean array. It's gonna be, let's call it positions. Well, let's just call it dynamic, because this is dynamic programming. So we are using an array to store information about the previous iteration. So this is typical dynamic programming method. So we'll just call it DP, all right? So there's normally be new Boolean. We will have, so the length of this dynamic array is gonna be a length plus 1. Why? Because we need to have the first element as the kind of like a dummy header, you know. So we start from the first element of the DP and we mark it true. We mark it true because starting from there we can do the iteration, not tour, but true. So, and let's do the conversion here. Okay, so for this, okay, now, so if the current position is true, now we're gonna start from the beginning, right? So if dp, let's say j, if dp j is true, which means, am I missing a parenthesis or something? Oh. Okay, so if this dp is true, which means there is a word before us. Now, what we need to do is we're going to have a, so this is going to be string, and we're going to have a word. No, we'll just call it substring, all right? So substring, you know what? I'll call it sub, okay? Substring, sub. You know, naming a variable is really struggling. You know what? I'll still call it substring, okay? Okay. So no, you know, and then substring, and then we're gonna have s dot substring, and it's going to be j plus 1, not exclamation mark, I, and well, it's the other way around. So it's going to be I plus 1, I plus 1, and j. Okay? All right. So if it's contained, if this substring comes from the dictionary, then we need to mark that position as mark the position of the last index of that word to be true. So if substring, you know what? Let me call it word. If this word, all right, this word, now, if, you know what? Let's do dict. Contains word. Then what we need to do is dp I plus 1 is going to be true. Okay, now, and one problem with this is that when we need to have equal sign here, because now first of all we need to, because this is I plus 1, so if we do less than that, we won't be able to get the last character of this substring. All right, now I think we're pretty good. And then after that, we will return the last element. So it's going to be length, right? So whether we can return a, let me see how much time I got. Ah! I forgot to start the timer. How long has it been? Excuse me, let me check. I think, okay, I think I spent around, stupid, I forgot to start timer. All right, I think it's around, I think I spent, so it was, when I started, I think it was around 7:30. Right now it's 7:43, so I think I spent around 14 minutes or so. Let's call it 15 minutes. All right, let's Jesus, I need to get some vitamin from, yeah. Right now my brain is not functioning well. All right, so let's test it with some test cases. All right, let's just try with LeetCode. All right, so all right, so now we have dp of length and 9. All right, so first of all, this is true, and then we're gonna start from the first. We're gonna start from the first character, and then we will see I0 j is or equal to this. All right, that's no problem. And then we have a substring. So I think now we already have the first one as true. Now, so the first one, okay, this is the dp, right? This is the dp. This is the dp. All right. So the first element of dp is true, yes, because we already initialized it. Now, if it's contained in the, if this is contained blah 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 blah, substring is going to be 0 to 1. So L, all right. So L, okay. Is L contained? No. So L will remain false. All right. Okay. So now move on to the next iteration. So we have 1. So I is 1, and then so we have 0, 1. All right. 0, 1. All right, which is LE. So LE is not contained. E is not contained. We're gonna move on to the next iteration, and then we're gonna have LEE or LEE or EE or E. All right, they're not contained either. So now we have T, so which is LEET. Oh, okay, that one is contained, so we can put it into the DP and mark that as true. So it's gonna be like F, and we're gonna have well, T here, okay, so which is the position of the T of lead. Okay, so I think we're good. Let's do it. True. Okay, how about if I get rid of OE, it's still true. False. Interesting. So yeah, I think that's correct. Okay, so yep, let's submit it. Please. Accept it. Perfect. All right, so yes, it's pretty, I wouldn't say it's easy question, but definitely need some thoughts. I think the tricky part here is the initialization and also this I+1 thing. So I think someone's knocking the door. And this I+1 thing. And so don't forget to put I+1 because, all right, I gotta go. Anyways, see you next time and happy coding.